Hi guys, welcome back to the channel. So today we are going to be discussing about palindrome linked list. So before diving into the question, turn on your DSA mode and then let's get started. So we are given a head of the linked list, which will have the head of this particular linked list, where it is going to be pointing towards 1, and then we are going to have the total linked list as 1, 2, and then 2, and then 1, and then we need to return this particular linked list is palindrome or not. If it is a palindrome, then we are going to return as true. If it is not a palindrome, then we are going to return it as false. So if we take this particular example where we have 1, 2, and then 2, and then 1, this particular example, now we need to check this particular linked list is palindrome or not. To do that, I'll store the linked list in the array, and then it is going to be 1, 2, and then 2, and then again 1. After storing the linked list into the array, I'll check the first and then last element. Yeah, both are same. And then I'll go to the 2 and then 2. Both are same. Then I'm going to return this particular linked list is palindrome. Suppose let's say we do not want to use this particular extra space, and then we need to optimize it better, and then we should not use any extra space. For that, suppose let's say I want to compare this node. I want to compare this node with the last node of the linked list. And then for this particular node, I need to compare it with the second last. So to do that, I'll store the length of this particular linked list. So that is going to be n. That is going to be n. And then whenever I want to check this particular 1th node, I'm going to check the nth node from the particular node. Suppose let's say this is the first node, and then this is second node, this is third node, and then this is the fourth node. Now when I want to check this particular node, I am going to check n minus I minus 1. So this is going to be my first node, this is going to be my last node. So I am going to check, this is going to be n minus I plus 1. So I am going to check the last node. For this I am going to check the second last node. So whenever I want to check this particular node, I need to travel from here to here, and then again here, and then again here. That means I need to travel big of n time, and then to check all the nodes I need to travel big of n, and then again big of n, which is going to be big of n time complexity. For that much time complexity, it needs to be optimized to some better way. So to do that, we need to reverse this particular linked list and then check this particular linked list with the previous linked list, whichever is present. And then if both the linked lists are same, then we are going to say that this particular linked list is a palindrome. That means I'm going to reverse this again. So I'm going to reverse this. Then it becomes 1, 2, and then 2, and then 1. Now this is the linked list after reversing. So I'm going to check, I'm going to compare this and then this, and then this, and then this, and then this. But as we have seen, we need to keep the uh, previous linked list as well as the current linked list. For that, we are going to need extra space to use this particular linked list. That means we are using extra space. The time complexity is going to be big of n, the space complexity is going to be big of n. So we need to optimize this in a better way. That means we should not use any extra space. For that, instead of reversing the total linked list, we'll try to reverse only half of the linked list. That means I'm going to reverse this 2 and then this one, then it becomes 2 and then 1. Here it becomes 2 and then 1. After that, I'm going to compare 2 and then 2. This is going to be same 2, 1 and then 1. So then it becomes like it is a palindrome, and then I'm going to return the answer. So for that, I'm going to take two pointers, which is going to be slow and then fast pointer. The fast pointer is going to travel twice, and then slow pointer is going to travel once. So the slow will travel one step and then fast will travel one step. fast will travel 2 steps, and then slow will come here, and then fast becomes here. So whenever the fast next or fast becomes null, then I'm going to stop at this particular place. And then after stopping here, I'm going to reverse this particular linked list till I get the current node as this particular node. That means this linked list will be reversed. After reversing this particular linked list, I am going to check 2 and then 1 with 2 and then 1. Then both are same, then I am going to return the answer. So let us check if we have the hard length. That means we have slow pointer here and then fast pointer here. And then for the first step, it is going to travel slow here, and then fast is going to be here, and then slow here, and then fast is going to be here. Now whenever the fast next becomes null, we are going to stop at this particular case. For this we are going to stop at this particular case. So whenever we compare with the odd with the even, now we need to reverse the linked list, which we are going to reverse from this particular case until we get till the slow pointer. And then again when we want to compare, we are going to compare from slow next when it is odd, and then when it is even, we are going to compare from the slow itself. That we are going to know via fast pointer. If the fast pointer is not null, then it is going to be odd, and then we are going to start from slow next. If the fast pointer is null, then we are going to say this particular linked list is even. So we are going to start from slow itself. So let us go through the code, how we are going to write the code for this particular question. So we are going to take slow and then fast pointer, and then till fast becomes null and fast next becomes null, we are going to travel slow to slow next and then fast to fast next. This is going to be our iteration for every step which we are going to do. That is moving this slow to next step and then fast to next step. And then after traversing the till fast becomes null or fast next becomes null, we are going to stop at that particular case, and then we are going to reverse off of the linked list from head to till head becomes slow node. So we are going to take head and then stop node, and then previous node which will store the previous node of the current node, and then this is going to be current node, and then this is going to be the next node. Now I have the current node, and then I have the previous node, and then I have the next node. Now whenever the current node becomes stop node, that means this is a slow node, then at that particular case I'm going to stop, and then I'm going to return this particular previous node which will have the off reverse of the linked list. So I'm going to return that. Suppose let's say the current node is not a stop node, that means we are going to do the traversals, and then we are going to set the, and we are going to reverse the linked list. Suppose let's say I have this particular current node. Now when I set current node next to previous node, then I will not have the pointer to the next node. That means before doing current node next to previous node, I am going to set this next node as current node next. So this will be next node, and then current node next is I am going to set it to the previous node. And then after that we should do the iteration. That means this is the previous node, this is the current node, and then this is the next node. Suppose let's say I say current node to the next node. Now when I want to traverse the previous node to current node, then I don't have a pointer to travel. That means before doing current node to next node, I need to do previous node equal to current node, and then again after doing this I'm going to say current node equal to next node. So this is going to be my answer. And then whenever let's say this particular node is stop node, that means at this particular case I am going to stop, and then whatever the reverse of the linked list, I am going to return this particular reverse of the linked list. And then after reversing, we are going to check whether this particular fast node is null or not. Suppose let's say this fast node is null. That means I am going to check the palindrome from slow next. I am going to check the palindrome from slow next, which is 2 and then 1 and then 2 and then 1. And then if the fast node is not null, the fast node itself is null, then I am going to travel from slow itself. So if there exists a fast node, then I am going to start from slow node next, and then if it is not a, if the fast node itself is a null, then I am going to travel from slow itself. And then we are going to check this particular palindrome or not using two nodes, which is going to be head 1 and then head 2. I am going to store in node 1 and then node 2. Whenever we say one of the node becomes null, then we are going to say it is not a correct one. Suppose let's say if the node 1 is null and then node 2 is not null, then we are going to say this particular two nodes are not a palindrome. And then whenever these two values, suppose let's say it is 2 and then it is 5, then those two values doesn't match, so we are going to return it as false, that this particular palindrome is not, is this particular two linked list doesn't have the palindrome. And then we need to do the iteration like node 2 will be traversing to the node 2 next, and then node 1 will be traversing to the node 1 next. And then whenever we are going to return true, we need to make sure that node 1 will be null and then node 2 will be null, and then we are going to return this true. If one of them is null and then the other is not null, then we are going to say one of them has more nodes and then other has less node, then it is not a valid case. So that's why we are going to return it as false. So this might not occur as we are taking the same length. So if it is of different length, then we are going to consider this particular case. So if we come to the time and space complexity, the time complexity is going to be big O of n. Why? Because we are traversing with one loop and then we are not using two loops, one inside the other. So it is going to be big O of n. And then if we come to the space complexity, we are not creating any new nodes. We are just using the pointers to point to that particular node, which is going to be slow node and then stop node and then fast node and then current node and then next node. And then if we the space complexity is going to be big O of 1. Yeah, that's all for this video. Thanks for watching the video.